Most organizations buy Microsoft Fabric believing they just purchased a platform. One place, one bill, one governance model, and therefore one set of risks they can control. They are wrong. What they actually bought is governance theater plus cost entropy, a system that looks unified while decisions fragment across engines, people, and workspaces. And the bill doesn't care about your intent. It will happily monetize your confusion. This is going to map the failure modes, why they happen, why they persist, and why they're inevitable unless you enforce design, not etiquette. The foundational misunderstanding. Fabric is not a platform, it's a decision engine. Fabric gets sold as one platform. The UI supports that story. The marketing supports that story. Execs love that story because it sounds like consolidation. Fewer tools, fewer vendors, fewer invoices, fewer problems. Architecturally, it is something else. Fabric is a composed system of engines that share a control plane and a capacity pool and then make thousands of runtime decisions on your behalf. Those decisions don't align to your org chart. They don't align to your project boundaries. And they definitely don't align to the PowerPoint data strategy you presented to the steering committee. That distinction matters. A platform implies a consistent execution model, one set of guardrails, one predictable cost behavior, one place where intent becomes enforcement. Fabric behaves more like a distributed decision engine, a compiler for analytics workloads. You submit work, refreshes, queries, pipelines, notebooks, streaming, mirroring, and the system chooses how to run it within a shared set of constraints. And the moment you accept that, the governance story changes. Let's break down the 4 myths that create the rot. First, unified versus composed. Yes, you can build in one place, but behind the curtain, Fabric isn't one runtime. You have Power BI's semantic model behaviors. You have Spark-based workloads. You have warehouses with their own query patterns. You have Event House and KQL. You have Data Factory-style orchestration. You have background operations that no human asked for in a meeting, but the system executes anyway. One UI does not equal one execution model. In reality, it is many engines with one veneer, and every engine has different tuning knobs, different failure modes, and different cost signatures. Second myth, capacity is a boundary. Capacity is not a project boundary. It is not a tenant boundary. It is not a safety boundary. Capacity is a shared compute pool. So when Team A runs a heavy refresh, Team B doesn't just see slower dashboards. Team B inherits contention. Team B inherits throttling, Team B inherits the smoothing behavior, and then Team B files an incident. Not because they did something wrong, because the shared pool reallocated pressure. This is where deterministic planning dies. Executives want cost predictability. Architects want workload predictability. Capacity provides neither when you treat it as a shared commons without enforced allocation. The system did what it was designed to do. Share. You did what you always do. Assumed sharing would behave like isolation. It will not. Third myth, workspaces are governance. Workspaces look like containers, so people treat them like security boundaries and cost boundaries. They are neither. A workspace is a social structure, a collaboration container with permissions and artifacts. It is a place for people to build. That is not the same as a control structure, because workspaces don't inherently enforce isolation. They don't enforce lifecycle separation. They don't enforce cost accountability. They don't enforce that prod means anything other than a string in the workspace name. And once you put multiple workspaces on the same capacity, you've admitted the truth. The workspace boundary is performative. You can segment the catalog, you can segment permissions, but the actual execution pressure lands on the same compute. That means your governance model must be stronger than the workspace abstraction, or you're just organizing the chaos. Fourth myth, one lake is the governance plane. One lake is a storage plane. It's a unification layer for data placement and access patterns. It's good at being a shared lake, but storage is not governance. Governance is enforcement of intent. Who can create what, where, under which defaults, with which sensitivity, with which lineage, and with which lifecycle constraints. One lake can hold labels, it can hold shortcuts, it can hold data you wish was curated, but it cannot by itself prevent the classic behaviors. Just load it to my lakehouse. Just mirror it so I don't wait. Just make another semantic model because mine is urgent. The system incentives are speed now, debt later. One lake makes the speed now path easier. That's not a criticism. It's the reality of a shared lake in a platform built for adoption. So what's the consequence of all of this? Intent doesn't propagate. You, the architect, may have intent. This dataset is sensitive. This domain owns the metric. This workspace is prod. This capacity is critical. This pipeline is scheduled. This model is certified. But Fabric does not infer intent. It executes configuration. And configuration fragments across workspaces, capacities, identities, labels, domains, subdomains, artifacts, engines, and background operations. This is how policy turns into a probabilistic security model. You don't have a single control plane making deterministic decisions. You have many surfaces where creation is cheap and enforcement is optional. Every exception becomes an entropy generator. Every temporary workspace becomes permanent. Every just this once capacity scale-up becomes the new baseline. Everything clicked when the system is treated like an authorization compiler. It will compile whatever you feed it. If your rules are weak, it will compile weak outcomes at scale. So if Fabric is a decision engine, governance can't be a committee. It has to be deterministic constraints that change system behavior. Next, the governance theater. Policies that look mature on paper and change nothing in runtime reality. Governance theater, policies that don't change system behavior. Most Fabric governance programs fail the same way. They confuse visibility with control. They build a center of excellence. They write standards. They publish a Confluence page. They run enablement sessions. They create a request form for new workspaces. And then they call it governance. That is not governance. That is documentation of intent with no coupling to execution. The platform doesn't read your slide deck. It reads configuration. It reads permissions. It reads what the user can click, what the service principal can create, and what the capacity will execute when the refresh hits at 8:00 a.m. This is the uncomfortable truth. If a policy doesn't change what the system allows, it's not a policy, it's a suggestion. And Fabric is a suggestion-friendly environment. That's the whole adoption play. Creation is cheap, deployment is fast, self-service is the default, which means your governance program has to work against gravity, calmly, repeatedly, with enforcement. Now, let's talk about the three biggest forms of governance theater that show up in Fabric estates. First, naming conventions as entropy management cosplay. You'll see rules like all workspaces must be named BU platform NV purpose, or all lakehouses must start with LH, or all semantic models must include the domain. Fine, but naming conventions don't constrain behavior. They don't prevent a user from creating test2 final at 2 a.m. They don't prevent someone from publishing an uncertified dataset used by the CEO's dashboard. They don't prevent duplication. They don't prevent cross-domain data grabs. They don't prevent the bill. They create the illusion of structure, which is worse than no structure because it makes leadership think the mess is handled. Second, approval workflows that don't constrain execution paths. This one is my favorite because it's the most expensive theater. A team builds a form, request a workspace. The COE approves, everyone feels safe, a ticket gets closed, and then the user still has contributor in 10 other workspaces, can create a lakehouse anywhere they already have access, can create a semantic model against any data they can see, and can run refresh schedules that collide with the rest of the capacity. The approval workflow approved the creation of a container. It did not constrain the pathways that actually spend money and create risk. So what you get is a system where governance approves the front door, while the side doors remain unlocked. Shortcuts, mirroring, dataset duplication, ad hoc notebooks, refresh schedules, and background operations. Every unmanaged pathway becomes an entropy generator. Third, best practices without guardrails. This is where the COE publishes guidance. Use direct lake. Don't duplicate data. Use domains. Use sensitivity labels. Use certified datasets. Separate dev, test, prod. And then the platform offers no friction for ignoring any of it. So the estate becomes a museum of half-followed recommendations. The people who care comply. The people who ship things fast don't. And the people who get rewarded are the ones who deliver dashboards, not the ones who prevent architectural erosion. This is where audit success becomes the final trap. Because audits love evidence, policies exist, training happened, there's a governance committee, workspaces have owners, sensitivity labels are available, there are quarterly reviews, the checkboxes light up. But audits don't measure runtime behavior, they don't measure whether your prod capacity got throttled by a dev notebook, they don't measure whether the same KPI exists in 5 semantic models, they don't measure whether your one lake strategy turned into a shared junk drawer full of mirrored copies and personal lakehouses. Passing an audit doesn't mean you have control, it means you have paperwork. And Fabric, like every distributed platform, punishes paperwork-first governance because drift is inevitable. Permissions expand, exceptions accumulate, teams change, dead artifacts stay alive, schedules stack, capacities get resized temporarily and never revisited. The platform did not betray you. You just tried to govern a decision engine with etiquette. So the test is simple. Does your governance change system behavior? Does it prevent creation without ownership? Does it block unsafe sharing paths? Does it enforce promotion gates? Does it quarantine non-compliant artifacts? Does it make cost visible and attributable at the moment of creation, not at invoice time? If not, you don't have governance. You have theater. Next, the bill exposes what governance hides, why Fabric spend drifts even when usage looks stable. Cost entropy, why Fabric spend drifts even when usage looks stable. Here's where the illusion collapses because money has no patience for your governance theater. Most teams look at Fabric cost drift and assume one of two stories. Either usage increased or someone is abusing the platform. Sometimes that's true, usually it's lazier than that. The real pattern is cost entropy. Spend rises because the estate accumulates coupling, background load, and contention even when the visible business workload looks stable. You still have the same reports, same refresh schedules, same number of users, Same datasets people point to in meetings, but the capacity burn climbs anyway. This is not mysterious. It's just shared compute plus growing uncertainty. Start with variable demand. Fabric workloads don't behave like a nice flat line. Interactive queries come in bursts, refreshes stack, pipelines overlap. Someone runs a notebook just to test something. Mirroring catches up, event streams continue to ingest, and all of that happens inside the same pool. So even if the average business usage stays stable, the shape of demand changes. Peaks get sharper, overlaps get more frequent. And in a shared pool, peaks are what you pay for operationally, even if you pay for capacity financially. This is where organizations confuse "I bought an F SKU" with "I bought predictable behavior." You didn't. You bought the right to compete for a shared scheduler. Now add the invisible coupling. In a well-governed architecture, Team A's workload should not become Team B's incident. In Fabric, if you don't enforce isolation, it will. The coupling is usually not malicious, it's accidental. The system invites it. 2 workspaces share a capacity, a third workspace gets added because it's temporary. A fourth gets added because it's just dev. Then the refresh windows collide, the interactive users hit at the same time, and the smoothing model quietly absorbs the damage until it can't. And when it can't, the symptoms show up somewhere else, not where the cause lives. That's what makes cost entropy so hard to fight. The operational pain doesn't line up with the organizational ownership. The capacity absorbs the blast radius. Then the most visible team screams first. Then you scale up to stabilize production, and the bill locks in the mistake. Now let's talk about background operations, because this is where most forecasts die. Fabric has work you didn't schedule. Internal operations that support the platform's promises. Power BI has background evaluation and refresh-related activity. Lakehouse and warehouse behaviors create their own maintenance patterns. Mirroring doesn't ask permission to keep itself current. Even metadata and caching behaviors exist to make interactive experiences feel fast. None of that is free, and it's not linear. Background load doesn't politely scale with your report count. It scales with sprawl. More artifacts, more models, more refresh definitions, more duplication pathways, more places the platform must keep ready. So the org thinks we didn't add users, but the platform thinks you added complexity, and complexity consumes compute. Now the weird part, the smoothing and throttling model turns deterministic planning into probabilistic reality. In a traditional isolated system, you can predict this refresh takes X minutes at Y time with Z impact. In a shared fabric capacity, the same refresh can behave differently day to day because it's contending with whatever else is happening in the pool. Smoothing makes this worse in one specific way. It delays the pain. Instead of immediate failure, the system tolerates bursts for a window, which sounds helpful, but it also makes teams believe they're safe. They aren't. They're borrowing from the future. And when the future arrives, the platform doesn't negotiate. It throttles, it queues, it slows, sometimes it fails. And now the human response is always the same. Increase capacity, because that's the one lever everyone understands. This is how cost drift becomes permanent, because capacity scaling is easy. Cost reduction is political. So forecasting without workload isolation becomes fiction. You can model average utilization, you can count refreshes, you can estimate query volume, but you cannot reliably forecast contention behavior when multiple teams share a pool and operate independently. The variance dominates the mean. What this actually means is simple. Fabric cost doesn't drift because you don't have dashboards. It drifts because you don't have boundaries. And if you don't believe that, you'll love the next trap. The metric tools exist. They're pretty, and they still tell the wrong story, Pet. The metrics trap. Capacity apps measure activity, not accountability. Now we get to the part where people feel safe again, because Microsoft gives you dashboards. Capacity metrics app, chargeback reports, CU seconds, pretty charts, trend lines, percentages that look like engineering. And everyone relaxes because the platform is measured. But this is the trap. These tools measure activity, not accountability. They answer what happened in the narrowest technical sense, and they rarely answer the only question the business cares about. Who owns this behavior, and what decision will change it? Start with the Capacity Metrics app. It tells you utilization, peaks, background versus interactive, top workspaces, top items, all useful. But it's still a view of physics, not meaning. Utilization doesn't tell you whether the compute produced value. It tells you the engine was busy. That's it. A CPU at 5% doing nonsense is still doing nonsense. A capacity at 80% serving duplicate semantic models is still serving duplicate semantic models. And the app can't tell the difference because it has no business semantics. It doesn't know which dataset represents an executive KPI. It doesn't know which notebook exists because someone forgot to turn off a scheduled run. It doesn't know which refresh is supporting revenue reporting and which refresh is feeding someone's personal sandbox. So teams optimize the wrong thing. They optimize utilization, not architecture. This might seem backwards, but low utilization is not a win in Fabric because capacity is a reservation, not a meter. If you bought the capacity and you keep it running, you pay whether it's busy or idle. 2% utilization isn't a badge of efficiency. It's evidence of overcommitment. It's proof you converted budget into unused headroom. And then leadership asks the obvious question, why are we paying for an empty parking lot? Now the chargeback story. Fabric chargeback reporting usually allocates cost by workspace, sometimes by item. And that sounds fair until you realize workspaces are social containers, not economic units. A workspace doesn't map cleanly to a product, a domain, a value stream, or a business outcome. It maps to who had access and clicked create. So when finance wants to know why the bill doubled, engineering hands them a report that says, this workspace used 38% of the capacity. Okay, what does that mean? It means the workspace participated in shared contention. It doesn't mean the workspace caused it. It doesn't mean the workspace benefited from it. And it doesn't mean the people responsible for the workload will feel pressure to change behavior. Because they can always move. They can split workloads into a new workspace. They can spread artifacts across multiple containers. They can create temporary workspaces. They can place the heavy stuff in a shared platform workspace and keep their consumer reports somewhere else. So workspace-based allocation becomes political, not corrective. The number is precise. The ownership is ambiguous. CU seconds are the purest form of this problem. CU seconds feel like truth. They're a real unit. They're granular. They look like billing-grade instrumentation. But CU seconds don't contain intent. They don't contain accountability, they contain consumption, and consumption in Fabric is often a symptom of prior architectural drift. Too many semantic models, too many refreshes, too much duplication, too much background work, too many engines running the same logic because nobody enforced reuse. So CU seconds become an input to conflict, not to design. The counterintuitive part is what gets optimized. Once you give teams a utilization chart, they will chase utilization. They'll reschedule refreshes to avoid peaks without reducing the number of refreshes. They'll tune one expensive query while leaving 3 duplicate models untouched. They'll optimize a notebook run while continuing to mirror data into 3 lakehouses because our team needs control. They will do local optimizations that preserve the global problem. Because the metric encourages tactical behavior, not structural change. And the structural change you need is boring. Fewer artifacts, fewer copies, fewer execution paths, stricter defaults, enforced ownership, and real lifecycle control. But your metrics app doesn't reward that. It rewards we reduced peak utilization by 10%. Meanwhile, the estate keeps growing. Here's the foundational misunderstanding behind the metrics trap. A capacity is not an accountability boundary. It is a shared execution pool. So any tooling that starts with capacity utilization is already one level too low. It's measuring engine pressure, not organizational responsibility. What this actually means is, don't ignore the metrics app. Use it as a smoke detector, but stop treating it as a governance model, because governance is not knowing that something burned. Governance is preventing ignition pathways in the first place. And the first ignition pathway in Fabric is where everyone pretends boundaries exist. The workspace. Workspace Sprawl, the default entropy generator. Workspaces are where Fabric entropy becomes physical. Not because workspaces are evil, because workspaces are easy. Creation is a 2-click decision with near zero immediate consequence. No architectural review, no cost signal, no lifecycle gate, no mandatory ownership model that bites you later. Just name, capacity, done. And the system law is simple. If it can be created without friction, it will be created without thought. So workspaces proliferate. They proliferate for legitimate reasons at first. A new project, a proof of concept, a merger, a new team, a vendor engagement, a temporary migration workspace. Then they proliferate for the reasons nobody admits: politics, speed, and avoiding governance, because the easiest way to bypass a messy conversation about ownership is to create a new container. This is why Workspace Sprawl isn't an accident, it's a platform incentive. Now the first rot is that dev, test, and prod collapse into whatever workspace exists. Every organization claims they separate environments. Most don't. They separate names. They'll have sales dev and sales prod and sales final and sales prod 2 because somebody needed to ship while access was being negotiated. Then the refresh schedules move. The pipelines get copied. The same semantic model definition shows up in 3 places with 3 different data sources because the team didn't want to break prod. And now you don't have environments. You have parallel universes. And when an executive asks, which one is the source of truth? And the answer becomes a sentence that starts with well. Second rot. Shared capacity makes workspace boundaries performative. You can pretend a workspace is isolated, but if it runs on the same capacity, it shares the scheduler, the smoothing model, and the pane. So the so-called dev workspace runs a notebook at 9:15 a.m., the prod workspace has a refresh at 9:20 a.m., and a critical report renders at 9:22 a.m. The capacity doesn't care what you wrote in the workspace name. It just sees concurrent pressure. So Sprawl doesn't just create more containers, it creates more chances for accidental collisions, more overlapping schedules, more independent teams tuning their own workloads without seeing the global impact. And because the coupling is invisible, everyone blames everyone else. Third rot, permission drift. Workspace permissions don't degrade because people are malicious. They degrade because work happens. A developer needs access just for today. A contractor needs access just for the sprint. An analyst needs contributor because viewer doesn't let them do the one thing they want. A manager becomes admin because someone has to approve a share. And you know where this goes. Over time, owners multiply, contributors proliferate, and the permission model becomes a social negotiation system. It stops being access control. It becomes access accretion. And in Fabric, access accretion has a unique problem. Permissions aren't just about viewing, they're about creation. If someone can create, they can create debt. They can create semantic models. They can schedule refreshes. They can publish reports that become business critical because someone bookmarked them. They can duplicate data into their own lakehouse for performance. So permission drift isn't just a security risk, it's a spend multiplier. And it grows without anyone noticing because each permission change looks harmless in isolation. Fourth rot, workspace ownership becomes a fiction. Most governance models say every workspace needs an owner. Great. But owner in practice means the person who created it, the person who inherited it, or the person who didn't dodge the meeting invite. That is not accountable ownership. Accountable ownership means someone is responsible for lifecycle, cost behavior, access pathways, and retirement. But retirement is where the entire model collapses because nobody gets promoted for shutting things down. So Sprawl accumulates dead assets, orphaned workspaces, forgotten models, pipelines that still run because turning them off might break something, and reports nobody uses but nobody dares delete. This is where the default Fabric estate becomes a graveyard of still billing artifacts. And you can't govern a graveyard with naming standards. What this actually means is the workspace is not just a container, it is the default entropy generator. Because it's the point where creation is cheap, permission drift begins, lifecycle becomes optional, and shared capacity turns separation into a story you tell auditors. Next, Fabric introduces domains and subdomains, and everyone expects that to fix the sprawl. It won't. Domains and subdomains, taxonomy without control. Domains show up right after workspace sprawl, like a cleanup crew arriving with clipboards. And executives love them because domains look like organizational alignment. Finance domain, sales domain, operations domain, clean labels, clean hierarchy, clean screenshots for a steering committee deck. But domains and subdomains as implemented are taxonomy, not control. That distinction matters because taxonomy is a story you tell humans. Control is behavior you enforce in systems. Fabric will happily let you build a beautifully organized catalog while the runtime continues to behave like a shared decision engine with no respect for your labels. Here's the foundational mistake. Leaders assume domains behave like boundaries. They don't domains group content. They help discovery. They help catalog navigation. They help you reduce the where is the thing problem. And that's real value. But it's not isolation. It's not policy distribution. It's not a security perimeter. It's not compute segmentation. It does not stop a refresh from colliding with a notebook in another domain because both can still sit on the same capacity. So when someone says we aligned Fabric to the business using domains, what they usually mean is we built a directory structure. That is not architecture. It's filing. Now, the next failure mode is subtler, the belief that business alignment equals enforcement. A domain can be named finance, but that doesn't mean finance owns the metric definitions. It doesn't mean finance controls the semantic layer. It doesn't mean finance controls the one-leg shortcuts pointing into their data. It doesn't mean finance decides what gets mirrored, duplicated, or certified. A domain label does not grant authority. And it definitely does not prevent the most common cross-domain behavior in Fabric data appropriation. A team in sales finds a finance table, needs it for a dashboard, and creates their own semantic model because it's faster than asking finance for a change. They might even copy the data for performance or for stability. Now you have multiple definitions of the same numbers, spread across domains, all labeled neatly. The catalog looks aligned. The truth is fractured. Subdomains make this worse when they're used as a substitute for ownership. People add subdomains like they add folders, North America, EMEA, product, customer, reporting, analytics. It feels like progress. It creates the appearance of a mature information architecture. But labels don't stop duplication. Labels don't stop drift. Labels don't stop cost. They don't stop the same data set from being recreated 5 times because each team insists they need their own version. And because Fabric is optimized for self-service, the system does not naturally converge. It diverges. Over time, subdomains become a map of organizational politics rather than a map of data products. You'll see the same content duplicated across subdomains because nobody wants to be dependent on anyone else, and nobody wants to accept a shared support model. The executive dashboard view is the ultimate deception here. Domains and subdomains generate top-level structure that makes leadership feel like governance exists. You can show charts, number of items per domain, activity per domain, top consumers per domain. You can create the illusion of accountability, but the rot underneath continues. Identical metrics, inconsistent definitions, unclear owners, unmanaged refresh schedules, and shared capacity contention that doesn't care about your taxonomy. What domains should have been is obvious: policy distribution points. In a deterministic governance model, a domain isn't a label, it's a control boundary where defaults and constraints propagate. Creation rules: who can create which artifact types inside the domain. Ownership rules: every artifact must have an accountable owner tied to a real team. Sensitivity rules: baseline labeling and access pathways required for the domain. Lifecycle rules: promotion gates and retirement expectations enforced by automation. Cost rules: budgets and thresholds tied to domain behavior, not just workspace activity. In other words, domains should have acted like an authorization compiler target. If you're building in this domain, these constraints apply. But without enforcement, you get the comfortable outcome. Neat categorization with no change in runtime behavior. So domains are not useless, they are just insufficient. They can help you discover and communicate structure. They can reduce catalog chaos. They can support executive reporting, but they cannot prevent entropy. Not when creation is still cheap, ownership is still optional, and capacities remain shared pools where contention ignores your org chart. And this is why the next expectation is so predictable. Once domains fail to create order, everyone looks to OneLake for the magic. They're about to be disappointed. OneLake, the OneDrive for data metaphor that misleads leaders. OneLake gets pitched with a metaphor that leaders instantly understand. It's OneDrive for data. That metaphor is convenient. It is also misleading, because OneDrive works like a personal file cabinet with sharing. It implies ownership. It implies a default boundary, my stuff, and then stuff I shared. It implies a primary access path and a recognizable permission model. And most importantly, it implies that centralization equals control. OneLake does not behave like that. OneLake is a storage plane that multiple engines can read and write through multiple pathways with multiple copies and references, all while your organization tells itself a story about single source of truth. What this actually means is OneLake centralizes placement, not responsibility. And centralizing placement without enforced responsibility just creates a more efficient way to accumulate junk. Here's what most people miss. OneLake is not a single copy guarantee. It is a single namespace with multiple ways to materialize data. You can land data, you can shortcut it, you can mirror it, you can write it through pipelines, you can create it through notebooks, you can ingest streaming and persist it. And you can do all of that across workspaces, domains, and engines. So the executive hears OneLake and assumes one version. The architect hears OneLake and should assume one battlefield. Because a shared storage plane does not eliminate fragmentation. It just moves fragmentation upstream into how data gets into that plane and how many teams decide they need their own representation of it. That distinction matters. Now add shortcuts. Shortcuts are genuinely useful. They can reduce copying when teams accept shared ownership and shared lifecycle. But shortcuts also expose the cultural truth. Most teams don't want shared ownership. They want independent delivery with no dependency risk. So what happens? Teams avoid shortcuts when shortcuts require coordination. They use shortcuts when shortcuts let them bypass a conversation. And when shortcuts aren't used, the fallback path becomes predictable. Copy it into my lakehouse. So OneLake becomes a centralization layer that still hosts multiple versions of the same thing because the platform can't enforce the social contract required to keep one copy true. Now add mirroring. Mirroring is another adoption accelerant. It gets operational data into OneLake fast, with minimal engineering friction. Great, but it also changes data gravity. Once mirroring exists, everything wants to land in OneLake because OneLake becomes the easiest place to build analytics. And that gravitational pull is not neutral. It drags incomplete governance along with it. You end up with mirrored operational data that looks official because it's centralized but still lacks the things governance needs to stay deterministic: explicit ownership, clear consumption contracts, controlled exposure pathways, and lifecycle rules about what gets created downstream. So leaders say, we mirrored the data, now the analytics team can self-serve. And the platform hears, we will multiply semantic models and refresh schedules until the capacity throttles. This is where sensitivity labels show up in the story as the comforting solution. Yes, labels help, they are necessary. But they don't solve access pathways. A label can follow a file, it can follow a table, it can inform downstream tools, it can trigger DLP policies and reduce obvious leakage, but it can't stop the two most common OneLake failures. First, the shared junk drawer. If OneLake is the place where everyone lands data for later, then OneLake becomes a landfill of half-modeled tables, ad hoc files, experimental notebooks, and multiple copies of datasets with slightly different names. Centralization doesn't prevent junk, it just makes junk easier to find. Second, governance lag. Data lands faster than governance can assign ownership, certify definitions, and enforce lifecycle. That means the estate becomes time-based. The newest thing is the thing people use, not the governed thing. And once people build reports on the newest thing, that thing becomes critical, and now you are retroactively trying to govern a dependency chain you didn't approve. Fabric is not unique here. This is what happens in every self-service environment when the storage plane is easy and the control plane is optional. And there's a final problem with the OneDrive metaphor. It frames OneLake as a collaboration convenience, but you are not collaborating on files. You are operating an authorization graph. Every shortcut, every mirror, every table, every semantic model, every refresh schedule, every shared item is a new edge in that graph. And edges accumulate. They do not self-heal. They do not retire themselves. They become permanent until you enforce deletion. So OneLake becomes the shared center of gravity for the estate. And gravity always wins. If you don't enforce constraints on what can land, how it can be reused, and who is accountable for it, OneLake doesn't simplify governance. It concentrates your failure into a single place. Next, the duplication pathways, shortcuts, copies, mirroring, and zero ETL, where the cost and trust rot quietly compounds. Duplication pathways, shortcuts, copies, mirroring, and the illusion of zero ETL. Duplication is the silent killer in Fabric because it looks like progress. A team lands data once, then another team reuses it by copying it into their own lakehouse. Then someone mirrors the source system, so we're not blocked. Then a third team builds a semantic model directly over their copy because the original one is too slow or owned by someone else. And suddenly your unified platform contains 3 versions of the same truth, not maliciously, predictably. Here's what most people miss. Fabric didn't create duplication. It removed the friction that used to limit duplication. It made the easy path faster than the correct path. Start with shortcuts. Shortcuts are the closest thing Fabric has to an anti-entropy mechanism. They let you reference data without copying it. In a sane world, shortcuts would become the default. One copy, many consumers, shared ownership, shared lifecycle, shared truth. But shortcuts come with a requirement that most organizations refuse to meet: trust. If Team A shortcuts Team B's data, Team A has accepted dependency. That means Team A is now exposed to Team B's schema changes, refresh timing, access decisions, retention rules, and incident response quality. And Team A doesn't want that. So shortcuts get used in the narrow cases where dependency risk is low or where a central platform team forces it. Everywhere else, teams choose the path that guarantees local control: copy. And copying is where both cost and governance rot compound. Because once you copy data, you also copy responsibility. Except nobody agrees to own the copied version. They just use it. Now mirroring. Mirroring sells itself as zero ETL, and leaders here: less engineering, faster analytics, fewer pipelines. Again, convenient. Again, misleading. Mirroring is not no work. It is work you no longer control. It creates a new ingestion pathway that runs continuously, and it changes who gets blamed when data looks wrong. The source team says, that's what the system produced. The analytics team says, that's the data we got. And now governance has to deal with a third party, the platform itself, executing sync logic on your behalf. Mirroring also multiplies downstream consumption because it makes data feel official. Once data is mirrored into OneLake, every team treats it as available. And available turns into allowed inside self-service cultures. People don't wait for curated products. They build now and argue later. So mirroring accelerates ingestion, but it also accelerates duplication. Multiple lakehouses layering transformations over the same mirrored base, multiple semantic models over similar structures, multiple refresh schedules fighting for the same capacity pool. You didn't remove ETL, you distributed it. Now the most common phrase in Fabric estates: just load it to my lakehouse. That sentence is not a technical decision. It's an organizational confession. It means the organization lacks a trusted shared layer, lacks a product ownership model, and lacks enforced consumption pathways. So individuals create private certainty, and private certainty is expensive because a lakehouse copy is not just storage. It is compute, ingestion, transformation, refresh, indexing, caching behaviors, background operations, and repeated query work across multiple engines. Every copy becomes its own gravitational center. It attracts its own semantic model, its own dashboards, its own "this is critical" stories. Then you get the next layer of entropy, multiple semantic models over similar data. This is where trust dies. The business doesn't care that the data came from the same source system. They care that the KPI is consistent. But when 5 teams build 5 semantic models, you get 5 definitions. Even if they all start identical, they won't stay identical because drift is the default state of unmanaged artifacts. And here's the uncomfortable truth. Direct lake speed can make this worse because it reduces the pain that used to force rationalization. When everything is fast enough, nobody consolidates. They proliferate. So why does the system incentivize this? Because the platform rewards speed now and externalizes debt later. Fabric makes it easy to create artifacts, easy to duplicate, easy to mirror, easy to build semantic models quickly, easy to refresh, easy to publish. It is an adoption engine, but adoption engines create debt unless you enforce constraints. So the illusion of zero ETL becomes zero accountability. The pathways multiply, the copies accumulate, and the bill grows while everyone insists usage is stable. Next, once the data exists in multiple forms, the engines start disagreeing. Lakehouse versus Warehouse versus Event House versus Power BI, all sharing one bill and one capacity scheduler. Multi-engine reality, Lakehouse versus Warehouse versus Event House versus Power BI. Fabric pretends you bought one experience. What you actually bought is a portfolio of engines with different rules, different optimizers, and different cost behaviors. Then you stapled them to the same capacity bill. That is not simplification, that is consolidation of blast radius. Lakehouse is Spark first and file first. Warehouse is SQL first with its own execution model. Event House is KQL first and time series optimized. Power BI is semantic first and interaction driven. Each engine exists because it solves a different class of problem. But Fabric markets the boundary as just choose the item. And that's where the rot begins, because teams treat engine choice like UI preference. I like SQL, so Warehouse. I like notebooks, so Lakehouse. We have streaming, so Event House. We need dashboards, so Power BI. That is not architecture. That is tool comfort disguised as strategy. The system consequence is predictable. The same data lands in multiple engines, in multiple representations, with multiple refresh patterns, each consuming the same capacity pool in different ways. And then you wonder why the bill is confusing. Here's the uncomfortable truth. Some query patterns are cheap in one engine and expensive in another. A wide scan over delta tables might be tolerable in Spark when you batch it, but expensive when it's driven by interactive slicing. A star schema style query might feel natural in a warehouse, but the moment you bolt on multiple transformations upstream and keep rematerializing, the cost moves. Event House might make ingestion and time window queries feel effortless, but if you start using it as a general purpose store because it feels fast, you'll pay for that illusion later in retention, hot cache behavior, and downstream duplication. And Power BI is its own category of cost behavior. It doesn't just run queries, it creates an interaction surface that triggers compute at the speed of curiosity. If the model is clean, this is fine. If the model is proliferating, it becomes death by 1,000 clicks. Now add the most common multi-engine failure mode. Same data, multiple representations. Teams will mirror a database for freshness. Then they'll land a copy into a lakehouse for transformation. Then they'll build a warehouse for SQL users. Then they'll build a semantic model for the exec dashboard. 4 engines, 1 dataset, 4 cost signatures. And the platform doesn't stop you because nothing in Fabric's default posture says this is the canonical representation. Everything else is forbidden. So the estate converges on redundancy. That redundancy creates confusion in performance tuning too. One engine hides another engine's constraints. People see a slow report and start tuning DAX measures when the real bottleneck is upstream contention on the capacity. Or they see a slow query and start indexing in the warehouse while the real issue is that the same data got duplicated and refreshed 3 times before the query even ran. The engines aren't cooperating, they're competing. And because you are paying at the capacity layer, you don't get a clean bill per engine. You get a shared pool where workload types collide. Interactive and background, streaming and batch, notebook and refresh, SQL query and model render. This is where the one experience story does the most damage. It hides that you're operating multiple runtimes that require different governance models. Lakehouse needs guardrails on notebooks, job scheduling, and data product boundaries. Warehouse needs guardrails on schema ownership, query patterns, and consumer concurrency. Event House needs guardrails on ingestion patterns, retention, and downstream export pathways. Power BI needs guardrails on semantic model ownership, refresh cadence, and metric definition control. If you apply one generic governance template to all of them, naming, a COE, a request form, you will get the same outcome, conditional chaos, because the weakest control plane governs the portfolio. And the weakest control plane in most orgs is the semantic layer, the part that turns data into meaning and then exposes that meaning to everyone. That's where the next failure mode lives, semantic model entropy, where self-service becomes self-harm. Semantic model entropy, where self-service becomes self-harm. This is where Fabric's governance illusion turns into executive-grade damage, because the semantic model is the product, not the lakehouse, not the warehouse, not the pipeline. Those are plumbing. The semantic layer is where raw data becomes a number someone will bet a budget on. And Fabric makes that layer easy to create, so it gets created. A lot. Self-service sounds empowering, but in a shared capacity environment, unmanaged self-service is just self-harm with a Microsoft logo on it. The foundational mistake is treating semantic models as disposable artifacts. They aren't. A semantic model is an agreement: definitions, relationships, measures, filters, security rules, refresh behavior, and performance assumptions. When you allow everyone to mint their own agreements, you don't get agility. You get a combinatorial explosion of meaning, and meaning doesn't reconcile itself. The first entropy pattern is dataset proliferation. Someone needs a report quickly. They create a model. They publish. It works. Then someone else needs the same report but with one extra column, and instead of extending the shared model, they copy it. Or they connect directly to the lakehouse and create a new model just for this use case. Or they build a thin model on top of a thick model because the UI makes that feel like progress. Fabric doesn't block that behavior, it accelerates it. So you end up with dozens, then hundreds of semantic models that differ by accident, not by design. They differ in measures, they differ in filter logic, they differ in time intelligence, they differ in which tables got included, they differ in relationship direction, they differ in who has access. And then you get the executive moment: two dashboards, same KPI name, different number. That's not a data problem, that's a semantic governance failure. Now add metric drift. A KPI isn't a number, it's a definition under pressure. Revenue becomes revenue excluding refunds, becomes revenue excluding refunds but including credits, becomes revenue excluding refunds but including credits, but only for shipped orders. Every team thinks their version is reasonable. Every version might even be defensible, but the business needs one version. If you don't enforce a canonical semantic layer, you create an environment where every team ships their own truth. And then executives stop trusting any of it. Not because the math is wrong, because the meaning is unstable. Here's the part nobody likes hearing. Promoted and certified are not governance. They are labels. They are signals. They are not constraints. A dataset can be certified and still be duplicated. A model can be promoted and still be bypassed. A certified model can be too slow, too rigid, or too politically owned, so teams build around it. Certification doesn't stop sprawl, it documents sprawl. Now we talk about direct lake because it's the perfect example of comfort creating rot. Direct lake is fast. It's also seductive. It removes some of the friction that used to force architects to think, do we really need another dataset? Do we really want to refresh this again? Do we really want to import this data into yet another model? When the model feels instant, people stop thinking about its life cycle. And when people stop thinking about life cycle, artifacts never die. So direct lake can become a multiplier of semantic model entropy because the performance is good enough that nobody feels pain early. You don't feel the cost of proliferation until the portfolio is large, the capacity is contested, and the refresh schedules stack. Then you feel it all at once. And because the pain shows up as capacity issues, the response is usually scale up, not delete models. That's how semantic entropy becomes cost entropy. Now add security and access behavior. Row-level security, object-level security, sensitivity labels, and sharing policies all interact with semantic models. When models proliferate, you proliferate security policy surfaces too. Each model becomes a separate authorization decision graph. Each one must be reviewed, tested, and maintained. Nobody does that at scale. So security becomes probabilistic. We think it's restricted. We think the right people have access. We think the model uses the governed table. You are no longer operating a deterministic security model. You're operating conditional chaos. And the final insult is that this all looks like success on paper. Look at the number of reports delivered. Look at the adoption. Look at the self-service. Until the CFO asks why the number changed. Until the CISO asks who can see what. Until the platform team gets paged because a refresh storm throttled the capacity. Semantic model entropy is where Fabric stops being a data platform and becomes a trust destruction machine. Next, once meaning drifts, forecasting and smart analytics become performance theater because you can't predict the future with a dataset you can't even define. Forecasting and smart analytics, garbage in, executive out. Forecasting is where leadership finally admits what they actually wanted all along, not dashboards, but decisions. They don't want to know what happened, they want to know what will happen, what to do about it, and whether the numbers can be trusted enough to justify a bet. And this is why forecasting is the most reliable lie detector in a Fabric estate. Because forecasting assumes stability. Stable definitions, stable history, stable data completeness, stable refresh behavior, stable lineage, stable ownership. It assumes your analytics layer behaves like an engineered system. Most Fabric estates behave like an ecosystem. Ecosystems don't forecast well. Start with the basic requirement. Seasonality and prediction only work when the past is coherent. That means your history must be complete and your meaning must be consistent. If the last 2 years of revenue are actually 3 different revenue definitions stitched together by dataset churn, your model will still forecast. It will just forecast nonsense. And the worst part is that it will forecast nonsense with confidence. The chart will be smooth. The line will look precise. The confidence interval will look scientific. The executive will nod and take the number into a budget meeting. This is the moment where governance debt becomes executive debt because dashboards can be ignored. Forecasts get acted on. Now add missing data. Most organizations assume missing data is obvious. It's not. In real-world Fabric estates, missing data gets introduced by drift. A pipeline breaks and gets silently rerouted. A table stops refreshing. A model switches from one lakehouse to another temporarily. A semantic definition changes. A filter logic gets modified. A data source gets mirrored in a new way. None of this raises a red flag in a meeting, but it destroys the integrity of time series. And time series forecasting is brutally literal. It will find patterns in whatever you feed it, even if those patterns are artifacts of your governance failures. The system doesn't know your pipeline broke. It just sees a dip. So it learns dips happen in Q4. Then next year, Q4 arrives and the model predicts a dip, and leadership underorders inventory, understaffs support, or cuts spend at the wrong time. This is how analytics becomes a force multiplier for error. The problem isn't that forecasting is bad. It's that forecasting amplifies whatever discipline you already have. If your history is stable, it helps you. If your history is chaotic, it operationalizes your chaos. Now we get to the modern excuse. Smart analytics, AI insights, Copilot, whatever branding is currently fashionable. These tools don't fix governance gaps. They build on top of them. They still need stable semantics. They still need lineage. They still need a canonical metric layer. They still need consistent access pathways. They still need data quality guardrails that catch missing cycles, schema drift, and partial refreshes before an executive sees a polished story. Otherwise, you are automating the production of plausible misinformation. And the reason this is so seductive is that it feels like progress. You can take a messy model, drop in a forecasting visual, add a parameter, and generate a future. It looks like you leveled up from reporting to prediction. But you didn't. You just moved from describing rot to extrapolating it. Now connect it to cost entropy, because this is where the platform punishes you twice. Forecasting workloads are not free. They often encourage larger data sets, more refresh frequency, more exploration, more experimentation, more what-if analysis. That means more semantic models, more compute, more background operations, more interactive queries. So the estate pays for the privilege of producing forecasts it can't trust. And then leadership reacts in the only way leadership knows. They lose trust. They start questioning the numbers. They stop funding the platform team. They freeze capacity upgrades. They turn every analytics initiative into a political negotiation. This is the predictable end state, executive distrust of data. Not because Fabric can't do forecasting, because you try to do forecasting on top of semantic entropy, duplication pathways, workspace sprawl, and governance theater. Garbage in, executive out. So when someone says, we're going to add forecasting to prove value, the answer is simple. Forecasting doesn't prove value. It proves whether you have control. And when you don't, the organization reaches for the next comforting distraction. Polish the dashboards, standardize the UI, build a design system. Because if the charts look consistent, maybe the meaning is consistent. It isn't. Next, why design systems fix the wrong layer first, and how they become the final stage of analytics performance theater. Design systems as a distraction. Consistency of UI isn't consistency of meaning. This is the stage of the program where the organization runs out of patience for invisible problems. Capacity feels unstable. Forecast looks suspicious. Executives start asking why the same KPI changes between meetings. And instead of fixing the semantic layer and the control plane, the organization does the most human thing possible. It fixes what it can see. It standardizes the dashboard, so you get a design system initiative, a theme file, a component library, a report template with approved fonts, colors, headers, navigation buttons, slicer placement, and a neat little last refreshed stamp in the corner like a credibility sticker. And yes, design systems can be useful, but only at the right layer. In Fabric estates, design systems become a distraction because they offer the feeling of governance without any governance of meaning. Visual consistency is not semantic consistency. A KPI card with the right color palette is still wrong if the measure definition drifted. A clean layout does not fix broken lineage. A standardized set of icons does not fix the fact that 3 teams each created their own revenue and all 3 are still running refresh schedules on the same shared capacity. Design is a presentation layer. Fabric rot happens in the decision layer. That distinction matters. Here's the mechanism. Design systems reduce ambiguity of interpretation, but they do not reduce ambiguity of source. They help a user navigate. They help a report look professional. They reduce cognitive load. They might even reduce support tickets like, where do I click? That's real value. But they don't answer the 2 questions that are destroying trust. Where did this number come from? And who owns it? So a design system is often the organization optimizing for first impressions because first impressions are measurable. Stakeholders can approve a mock-up. Leadership can see the before and after. Everyone can clap. Meanwhile, the same dataset proliferation continues under the surface because nothing in the design system changes what can be created, where it can be created, how it gets certified, or whether it gets retired. The weird part is that design systems can actually make the rot harder to detect. When every report looks the same, users assume the data behaves the same. Visual standardization creates implied standardization of meaning. It's an unearned trust signal. It makes inconsistent semantics feel consistent. And once you do that, you've built the perfect executive trap, a portfolio of dashboards that look unified while the underlying definitions quietly diverge. Now add the Power BI reality. Power BI makes it trivial to make something look polished. Themes apply fast, layouts replicate, templates copy-paste. You can turn a messy report into a professional report in an afternoon. But the back end, lineage, ownership, metric definitions, refresh behavior, capacity contention, still runs like a distributed system that nobody is governing deterministically. So you get a familiar failure mode. The org invests in design, not in meaning. And then leadership experiences a more expensive version of disappointment. But it looks governed. Yes, it looks governed. It isn't. This is also where teams confuse design systems with standardization. Standardization is an enforcement problem. A theme file is not enforcement, it's a convenience. If someone can publish a report without using the template, they will. If someone can create a dataset without registering ownership, they will. If someone can bypass the certified semantic model because it's easier, they will. And the platform will accept it. So design systems often become the last chapter of analytics performance theater, a lot of work that improves optics while the trust problem keeps compounding. Now, there is a sane place for design systems in a governed estate. They work when they sit downstream of enforced semantics, when you have a canonical semantic model per domain, when measures are controlled, when lineage is visible and accurate, when artifact creation is constrained by policy, not etiquette, when dev and prod are separated by enforced promotion, not folder naming. When cost behavior is monitored and acted on, then design becomes the final 10%, clarity and usability on top of a stable meaning layer. But if you apply design before you have deterministic semantics, you are just painting over cracks in a load-bearing wall. It might look better. It will fail anyway. And it fails in the most predictable way. While everyone debates UX, the compute bill keeps running. Because the platform doesn't charge you for ugly, it charges you for behavior. So if you want a simple rule, use design systems to reduce user confusion, not to reduce governance risk. If you want to reduce governance risk, you need constraints that change system behavior. And that means the next topic, capacity chaos, where start small and scale quietly turns into permanent over-provisioning. Capacity chaos, when start small and scale turns into permanent over-provisioning. Now we get to the move every Fabric program makes eventually, capacity escalation as a substitute for design. It starts innocently, someone enables the trial, the org gets an F64 for free, everything feels fast, everyone gets addicted to no friction. Then the trial ends, reality arrives, and the first paid capacity gets purchased. Usually starts small, F2, F4, maybe F8. And within weeks, someone says the fatal sentence, we need to scale up to stabilize, not to create value, to stabilize. That's when capacity stops being a deliberate choice and becomes a reflex. Here's why it happens. Shared capacity makes performance failures look like platform limitations. Throttling shows up, users complain, refreshers miss their window, reports spin, somebody screenshots a capacity metrics chart with a scary spike, then leadership asks for the fix, and the only fix that doesn't require a governance conversation is more capacity. Scaling is easy, it's a skewed drop-down, governance is not. So the platform gets bigger and the estate stays undisciplined. The weird part is that the bigger you go, the less incentive you have to fix root causes. Extra headroom masks architectural failures, duplicated semantic models, overlapping refresh storms, unnecessary pipelines, background operations piled on top of a shared scheduler. It all works again until it doesn't. Then you scale again. That's how start small and scale becomes permanent over-provisioning. Now let's talk about the lie people tell themselves at this stage. We can always pause or scale down later. Technically, yes. Operationally, no. Pausing and scaling down require certainty. They require you to know what workloads run when, what breaks if you stop, who will scream first, and what business process depends on which artifact. In a sprawl-driven Fabric estate, you don't have that certainty. You have folklore. Someone says, don't pause it, a refresh runs overnight. Someone else says, we've got pipelines on a schedule. Someone else says, APAC might be using it. Nobody knows. Nobody wants to be the one who finds out. So the capacity stays on forever. And the bill becomes a fixed cost with a vague value story attached. The next trap is scheduling. Everyone hears the same advice. Scale up during business hours, scale down at night, pause on weekends. And yes, you can automate this with Azure Automation Logic apps or scripts hitting the Fabric management APIs. But schedules fail for one reason. The workload isn't actually aligned to the clock. Pipelines don't only run in one window. Refreshers don't only run in one window. Notebooks get triggered by just testing. Mirroring continues. Streaming continues. Background operations continue. And because teams keep adding artifacts without a lifecycle gate, You accumulate long-tail activity that never stops. So the schedule becomes an incident generator. The org tries it once. Something breaks at 6:03 p.m. Someone gets paged. The capacity gets turned back on manually. The schedule gets disabled. Then everyone says, scheduling isn't realistic for us. No, your architecture isn't realistic for scheduling. Now add reserved instances because Microsoft will happily offer you discounts for committing to the mistake. Reservations make the spend look smarter. We saved 40%. But the reservation discount is not efficiency. It's commitment, and commitment encourages complacency. Once you reserve, the pain of turning it off feels higher because now the cost is psychologically prepaid. It becomes a sunk cost defense mechanism. We're already paying for it, so keep it running. This is how you end up with predictable cost and unpredictable value. A stable bill is not the same thing as a controlled estate. And there's one more brutal truth. Fabric scaling decisions are often made by the loudest team, not the most valuable workload. The team with the most executive visibility, the team with the most users, the team that complains fastest. Those teams get the capacity increased to protect the business. Meanwhile, the real driver might be an unmanaged dev workspace running a notebook loop or a duplicated semantic model refresh storm or a mirrored dataset with downstream copies stacking background compute. But that requires investigation. Scaling doesn't. So capacity chaos becomes the default operating mode. Buy bigger, hope the problem disappears, repeat. This is why in a rotting estate, your FinOps program ends up optimizing the invoice rather than controlling behavior. And the missing layer is obvious. Accountability tied to consumption, not chargeback theater, not utilization charts. Accountability that forces decisions. Retire, consolidate, enforce reuse, block creation, isolate workloads, or pay knowingly. Next, the org tries to solve that with chargeback, and it turns into fiction. Chargeback is fiction, allocation without ownership. Chargeback is where Fabric programs go to die politely because it sounds like accountability. It produces numbers, it produces spreadsheets, it produces meetings where finance finally feels included, and it produces the illusion that you can fix architectural drift with allocation math. You can't. Chargeback only works when ownership exists first, not someone has access, not someone created it. Ownership as in a named team that can make binding decisions about what gets built, what gets reused, what gets retired, and what gets funded. Most Fabric estates don't have that. So chargeback becomes reporting without consequences. Here's the core problem. Workspace-based chargeback turns a shared compute pool into a political boundary. Finance wants the bill broken down. Engineering wants the bill to stop being their problem. So you allocate costs by workspace, maybe by item, and you declare victory. Then the fights start. Because a workspace isn't a product. It's not a value stream. It's not a contract. It's a container that exists because someone needed a place to click new item. So when you allocate spend by workspace, you're not assigning cost to value. You're assigning cost to convenience. And people respond to incentives. Once teams know that cost will be attributed to their workspace, they do what every rational actor does inside a weak control plane. They move the workload. They split it, they rename it, they spread it, they tuck expensive things into shared workspaces, they publish consumer-facing reports in one place and run heavy refreshes somewhere else. They create platform workspaces that magically absorb cost because nobody wants to argue with the platform team. This isn't fraud, it's organizational physics. If the attribution model is easy to game, it will be gamed. And in Fabric, it is easy because the boundaries are social. Now add the next failure mode. Chargeback creates conflict, not change. You show a business unit they spent 40% of capacity. Their first response isn't, we should consolidate models. Their first response is, we didn't authorize that then. Then you spend 3 weeks debating which artifacts belong to which team, which refreshes count as shared services, and which workspaces should be exempt. Meanwhile, the capacity bill continues. The system doesn't stop billing while you argue, so chargeback becomes a quarterly ritual of resentment. Finance pushing for granularity, engineering pushing back on semantics, and business leaders treating the numbers like accusations. And even when the number is correct, it still doesn't force a decision, because cost without control is just guilt. The next problem is externalization. In a shared pool, it's always tempting to push cost outward. This dataset supports everyone. This pipeline is enterprise. This warehouse is shared. This domain is foundational. Sometimes that's true. But without a consumption contract, shared becomes a dumping ground for unowned workloads. The same way shared mailbox becomes the place where accountability goes to rot. Shared workspace becomes the place where compute goes to hide. And because chargeback tends to focus on who consumed, not why it exists, you end up punishing the consumers while the producers keep shipping new artifacts. That's backward. The producers control architecture. Consumers mostly inherit it. Now to the part leaders think will fix it, showback versus chargeback. Showback says, we're not billing you, we're just informing you. Chargeback says, we're billing you. Neither matters if the organization can't take action. The only model that works is one where ownership is coupled to lifecycle. Because spend is rarely the problem. Unretired assets are, duplicated models are, unbounded self-service is, refresh storms are, background operations that nobody revisits are. So a chargeback model that doesn't force lifecycle decisions is just accounting theater. What chargeback should have done is simple: force explicit trade-offs. If Team X wants to keep 10 semantic models, fine, but they should have to fund 10 semantic models. If they want to mirror data and then copy it into 3 lakehouses, fine, but they should have to justify the cost and accept the support burden and accept an end date. That requires ownership, not allocation. So the harsh truth is, when you implement chargeback in an estate without enforceable boundaries, you don't create accountability, you create survival strategies. And those strategies increase entropy. More workspaces, more fragmentation, more hidden coupling, more exceptions, more temporary artifacts that never die. The number gets cleaner, the architecture gets worse. So if you're determined to do chargeback, the rule is brutal and non-negotiable. Never allocate cost to a container. Allocate cost to an owner with the power to delete. That means a workload owner, a data product owner, a domain owner with enforcement authority, not a random workspace admin. And if you can't identify that owner, then the workload is ungoverned by definition. At that point, the only honest thing you can do is quarantine it. Because reporting spend on unowned assets doesn't reduce spend. It just documents your inability to control your own platform. Which brings us to the actual fix. The system needs guardrails that prevent entropy, not dashboards that describe it. The control plane you actually need, policy as an authorization compiler. So here's the part that actually fixes it. Not another committee, not another slide deck, not another center of excellence with a mailbox and a SharePoint site full of PDFs nobody reads. You need a control plane. And in Fabric terms, a control plane is not a dashboard that tells you what already happened. It's a set of constraints that decides what is allowed to exist in the first place, what defaults apply when it's created, and what happens when it drifts out of compliance. Governance is not documentation. It is denial. That sounds harsh. It's also how every stable system works. The system must be able to say no to bad structure at scale without human intervention. This is the uncomfortable truth. Most Fabric governance programs treat policy like advice. They publish standards. They publish recommended patterns. And they publish please don't. And then they act surprised when the platform becomes a landfill. Fabric doesn't run on your intentions. It runs on permissions, defaults, and automation. So treat policy like an authorization compiler. Think of it the same way a compiler treats code. You don't suggest syntax, you enforce it. If the code doesn't compile, it doesn't run. Full stop. Your Fabric estate needs the same posture. If an artifact doesn't conform to your rules, it doesn't get created, or it gets quarantined, or it gets downgraded to a non-production tier, something that changes behavior. Otherwise, your policy is just prose. Now, what does authorization compiler mean in practical terms? It means you define rules in 4 categories, and you enforce them at creation and continuously. First, creation constraints. Who can create workspaces? Who can create lakehouses? Who can create warehouses? Who can create semantic models? Who can create event streams, notebooks, pipelines? And not just who has permission, but who can create them in which zones? Because everyone can create everything everywhere is not self-service. It's uncontrolled manufacturing. Second, defaults that bite. Every created artifact must inherit required settings: naming, sensitivity labeling baselines, ownership metadata, and the right workspace capacity placement. You don't ask people to remember the rules. You make the rules the default. The platform already does this in small ways. You just haven't weaponized it. Third, authorization boundaries that are real, not domains as labels. Boundaries that map to enforcement decisions. Production zones with locked down creation paths. Dev zones where experimentation is allowed but isolated. And shared zones where reuse is mandatory and duplication is expensive. If you cannot enforce a boundary, it is not a boundary. It's an opinion. Fourth, consequences. This is where governance stops being theater. If someone violates the constraints, something happens. Revoke permissions, disable refresh, move the artifact to quarantine, block sharing, or force remediation before it can be promoted. Email is not a consequence. A ticket is not a consequence. A consequence is when the system refuses to continue until the structure is corrected. Now, minimum viable enforcement, because people love to pretend this requires a 2-year program. It doesn't. Start with the things that generate entropy fastest. Naming is not aesthetics. Naming is indexability and ownership detection. Ownership is not a field. Ownership is who gets paged and who gets charged. Sensitivity is not a checkbox. It's downstream access behavior and data loss pathways. Lineage is not a nice to have. It's the only way to answer, where did this come from? Without a meeting. Lifecycle is not cleanup later. Lifecycle is an end date, a retirement action, and a default that everything expires unless renewed. If you enforce only these 5, naming, ownership, sensitivity, lineage, lifecycle, you will remove more entropy than 100 dashboards ever will, because you will change what can be created and what is allowed to persist. And here's the rule that governs all of this, the one your estate currently violates. If it can be created without friction, it will be created without thought. Fabric is frictionless by design, so you must add friction by design, not by making users miserable, but by forcing intent to exist. Forcing someone to declare purpose, owner, and lifecycle before the platform allows the artifact to become real. That's what a control plane does. It turns self-service into bounded self-service, freedom inside constraints. And once you have that, you can finally do what every Fabric estate claims it will do but never does. You can enforce intent through lifecycle, not just at creation. That's next. Lifecycle governance, birth, promotion, retirement. Lifecycle governance is the part everyone promises and nobody funds. Because it isn't glamorous, it doesn't ship new dashboards, it doesn't make the quarterly update deck. It's just the mechanics of keeping a distributed platform from becoming a cemetery. And Fabric by design becomes a cemetery unless you treat lifecycle as a first-class control plane feature. Here's the core reframe. Every artifact is a liability until it proves it is a product. Lakehouse, warehouse, event house, pipeline, notebook, semantic model, report, dashboard, shortcut, mirror. They all start as experiments. The system doesn't know when an experiment became business critical. It just sees a growing graph of dependencies. So lifecycle is how you force intent to exist over time, not just at creation. Start with birth. Birth is not someone clicked new. Birth is when the organization agrees an artifact is allowed to exist in the estate with a declared purpose, a declared owner, and a declared expiration. Owner means a real team, not the person who created it. People leave. Teams persist. Purpose means the business decision it serves, not analytics. And expiration means a date, not a wish. Not we'll clean it up later. A date. Because in distributed platforms, later is the most expensive date on the calendar. So the first lifecycle gate is simple. No owner, no artifact. No purpose, no artifact. No end date, no artifact. That is not harsh. That is adulthood. Now promotion. Promotion is where Fabric estates fail hardest because they confuse etiquette with enforcement. They tell teams dev, test, prod should be separate. And then they implement it as naming conventions. Oh, dev and by prod sprinkled into workspace names like it means something. It doesn't. A promotion gate is a boundary that the system enforces. The artifact cannot become production without passing checks. And those checks are boring on purpose. They reduce the probability of surprise. At minimum, promotion should require a named owner and support model, lineage present and reviewable. Sensitivity labels correct. Access paths reviewed. Who can read, who can share, who can export. Cost behavior understood, refresh schedule, expected concurrency, expected data movement, and the crucial one, a rollback plan. If you can't roll it back, it's not production, it's a public experiment. In Fabric terms, promotion also means moving from works in my workspace to works in the estate. That means you don't just validate the report, you validate the runtime behavior, background operations, refresh overlap, notebook scheduling, capacity contention, and whether it degrades other workloads. Promotion is an architectural contract, not a deployment step. Now retirement. Retirement is the only scalable FinOps strategy you actually control. Right-sizing helps, scheduling helps, reservations help. Those are financial levers. Retirement is an architectural lever because dead assets still generate cost in Fabric even when nobody is looking at them. Refresh schedules, background optimization, retention, mirrored syncs, orphaned semantic models that keep running because someone might be using it. And the most reliable statement in any platform program is someone might be using it, which is why you need a deterministic retirement process that is designed to survive fear. Retirement isn't deletion first, it's deprecation first. You mark an artifact as deprecated, you surface it in the catalog, you warn consumers, you remove it from promoted status, you disable scheduled refresh, you watch for usage, you create a replacement path if one exists, then you delete. And you delete with confidence because the system recorded ownership, purpose, and consumers. And that's the point. Lifecycle isn't cleanup. Lifecycle is observability plus authority. Now connect this to data product thinking because it's the only mental model that makes lifecycle enforceable. A data product has consumers, an owner, an SLA or SLO, a definition, and a support boundary. It has a roadmap. It has a retirement plan. It has versioning. A random dataset does not. So you stop pretending every artifact is a product. Most artifacts should never be promoted. Most artifacts should expire. And that's fine. The failure is when expired artifacts remain running, consuming capacity, confusing users, and dragging your estate into permanent ambiguity. Fabric doesn't drift because you are careless. It drifts because the platform is unattended and creation is cheap. So treat lifecycle governance as non-negotiable. Birth with intent, promotion with enforced gates, and retirement as a default outcome. Then the estate starts behaving like an engineered system. Without it, it behaves like a landfill with a GUI. FinOps for Fabric, from cost reporting to behavioral control. FinOps for Fabric isn't a dashboard. It's not a monthly email with a CSV. It's not a cost review meeting where everyone nods and nothing changes. FinOps is behavioral control. If spend stays flat but architecture keeps rotting, you didn't do FinOps. You did accounting. This is the uncomfortable truth. Fabric cost is a symptom of permissions and defaults. It is the byproduct of what the platform allows people to create, how long it allows it to live, and how many times it allows the same data to be rematerialized. If you don't change those behaviors, you will only ever get better at watching the bill arrive. So the real FinOps move is to stop asking how much did we spend and start asking what behavior did we fund? Because cost in Fabric is not a meter on a single workload. It is contention in a shared pool. It is background work you didn't schedule. It is refresh patterns you didn't standardize. It is duplication you didn't prevent. It is semantic models you didn't retire. In other words, it is governance expressed as money. That distinction matters. Now, the first trap is optimizing CU charts. Capacity utilization feels objective. CU seconds feel precise. The Capacity Metrics app gives you curves, spikes, and heat maps that look like truth. But utilization is not accountability. Utilization doesn't tell you whether the work created value, whether it created trust, or whether it created another artifact that will haunt you for 2 years. A capacity can run at 10% and still be pure waste. A capacity can run at 80% and still be the best money you spend. FinOps is not get utilization up. That's a data center mindset. Fabric is not a data center. It's a shared decision engine billing you for entropy. So instead of worshiping utilization, you need unit economics tied to decisions. Cost per decision, cost per dataset, cost per refresh, cost per domain, cost per report, render. Those metrics force the right conversations because they collapse the fantasy that self-service is free. Every refresh is a decision to burn compute. Every duplicated dataset is a decision to multiply downstream cost. Every extra semantic model is a decision to multiply meaning drift. And those decisions should have owners. So the second move in Fabric FinOps is to connect cost to a control loop. Reporting without consequences is theater. Thresholds without automation are email spam. If you want the estate to behave, the platform must react. Budget thresholds tied to action. Not notify the team. Action, scale down dev capacities outside business hours automatically because dev environments are not sacred. Pause capacities when nothing is scheduled to run because someone might be using it is not a business case. Quarantine workspaces that exceed policy. Too many semantic models, no owners, no lifecycle metadata, excessive refresh frequency, high background utilization with low consumption value. The point isn't to be punitive. The point is to make cost a feedback signal that changes build behavior. Because in platforms, behavior follows incentives. Right now, the incentive in most Fabric tenants is create anything, anytime, and the bill becomes central IT's problem. That incentive produces the exact estate you deserve. So align finance and engineering with shared definitions and shared consequences. Finance doesn't care about CU seconds. Engineering doesn't care about cost center allocations. So you need translation, a small set of metrics that both sides can defend, and a workflow that turns those metrics into decisions. Decision 1, consolidate or keep duplicating. Decision 2, promote to prod or keep as dev. Decision 3, refresh frequency or stale tolerance. Decision 4, retire or fund. FinOps that doesn't force these decisions is just reporting. And this is where governance and FinOps merge. Lifecycle enforcement is FinOps. Creation constraints are FinOps. Canonical semantic models are FinOps, because the cheapest workload in Fabric is the one you never allowed to exist. So the practical model is simple. Define cost policies the same way you define security policies. You don't recommend encryption, you enforce it. Do the same with spend behavior. Set a budget per domain. Set an allowed artifact count per workspace tier. Set a maximum refresh cadence for non-prod. Set a maximum number of semantic models per dataset boundary. Then automate enforcement. And yes, this means some people will be blocked. Good blocked creation is how you stop entropy at scale. Because your estate is not failing due to a lack of dashboards. It is failing due to a lack of constraints. Next, the platform level implication is obvious. Automation isn't optional. It's the only enforcement mechanism that scales faster than your users can create new artifacts. Automation as enforcement, using the platform against entropy. Automation is where governance stops being a mood and becomes a mechanism. People love to describe Fabric governance as process. Process is human. Humans get tired. Humans change roles. Humans ignore emails. Humans approve exceptions because someone senior asked nicely. Automation doesn't. In a platform that can mint new artifacts in seconds, the only control surface that scales is the one that operates at platform speed. That means rules expressed as code, enforced continuously, with consequences that don't require a meeting. This is the uncomfortable truth. In Fabric, every manual control becomes optional over time. Every optional control becomes drift, and drift becomes cost. So the goal of automation isn't convenience, it's entropy management. Start with scheduled capacity scaling. Yes, it's useful. No, it's not a strategy. If you scale down every night and scale up every morning, but your estate has uncontrolled refresh storms and background operations that run whenever they feel like it, the schedule will become a recurring incident. Schedules only work when the workload truth matches the schedule truth. So the real automation pattern is measure behavior, then change behavior. Not pick a time, hope nothing breaks. That means you automate around the signals that actually predict pain. Sustained throttling, sustained smoothing dead, abnormal background utilization, and refresh overlap that correlates with user complaints. Those are operational signals. You treat them like circuit breakers. If the estate hits a defined threshold, the system reacts, notifies, yes, but also reacts. Now, alerts. Most orgs already have alerts. What they have is email. Email is how you outsource consequences to people who will ignore them. An alert only matters when it triggers action, scale, pause, block, quarantine, or revoke. Otherwise, it's telemetry for your guild. So the practical model is simple. Tie alerts to runbooks and tie runbooks to APIs. Fabric has management endpoints. Azure has automation primitives. Logic apps exists. Functions exist. Scheduled jobs exist. Pick your poison. The point is, the platform must be able to change its own posture when thresholds are met. Now, the part everyone dodges, policy-driven provisioning. If you let people create workspaces freely, they will create workspaces freely. If you let people create lakehouses and semantic models with no defaults, they will create them without defaults. Then you will spend your life retrofitting governance onto artifacts that never should have existed. So you invert it. You create golden paths and you automate creation through them. A new workspace request shouldn't create a workspace. It should compile a standard environment, correct naming, correct capacity placement, correct default permissions, correct label baselines, required ownership metadata, and a lifecycle timer that starts on day one. And if the request doesn't supply the metadata required to compile the workspace, the request fails. That is governance. That's what policy as an authorization compiler looks like in code. Next, continuous audit with consequences. Point-in-time audits are theater because Fabric is not static. It is a living system. So you audit continuously. Owners still present, refresh schedules still justified, data sets still referenced, models still certified correctly, sharing still within policy, sensitivity labels still aligned, and the artifact count still within tier limits. Then you act. If an artifact drifts, downgrade it, remove promotion, disable refresh, quarantine it to a non-prod capacity, revoke sharing rights, require remediation before reactivation. This is the part governance committees hate because it removes negotiation. Good. Negotiation is how Entropy wins. And yes, you will get pushback. Every automated control will produce one of two responses. This is blocking my work, or can we get an exception? Exceptions are entropy generators. So you treat exceptions like production deployments, time-bound, reviewed, and revoked automatically, unless renewed with justification. An exception should expire by default because otherwise it becomes the new baseline. That's how policy erodes. Now, the simplest automation lever that most people ignore, retirement automation. If an artifact hasn't been used in N days, it gets marked deprecated automatically. If it stays unused, refresh gets disabled. If it stays unused longer, it gets deleted. If someone wants to keep it, they must reassert ownership and purpose. This is how you stop paying for dead things. And the system law underneath all of this is boring and absolute unattended platforms drift toward waste. So if you want Fabric to behave like an engineered system, you stop managing it and you start enforcing it. Automation isn't optional. It's the only thing faster than Sprawl. Executive reality check. What good looks like in a Fabric estate. Executives don't care about your lakehouse strategy. They care about whether the numbers stay the same long enough to run the business. So here's what good actually looks like in a Fabric estate. When the governance illusion dies and the system finally behaves, first, fewer artifacts. Not because the platform can't scale, but because your organization can't reason about unlimited objects. Good estates don't celebrate how many reports shipped. They celebrate how many reports didn't need to exist because the canonical product already solved the question. A healthy estate has reuse pressure. A rotting estate has creation gravity. Second, ownership is obvious and it's enforceable. Not this was built by Alex in 2023. That's trivia. Real ownership is a team name, a support boundary, and a decision right. The owner can change refresh cadence. The owner can retire assets. The owner gets paged. The owner has budget authority. If you can't point to an owner in under 10 seconds, you don't have an asset. You have an orphan. Third, self-service exists, but it's bounded. The estate has safe zones for experimentation and hard walls for production. In dev, people can move fast and break things. In prod, people can move carefully and prove things. The wall between those two isn't etiquette. It's enforced. That means promotion gates, enforced defaults, and permissions that don't drift because someone got added just for today. In good estates, just add me is treated like opening a firewall rule. It's a request with an owner and an expiry. Fourth, meaning is stable. Executives can look at two dashboards and see the same number because the semantic layer is treated like the product it is. There is a canonical model per domain, and the organization invests in it the way it invests in any other shared service: design, testing, versioning, and retirement. Certified isn't a sticker, it's the default path, and anything that wants to compete with the canonical model must justify why, with a time limit. Fifth, lineage works in the direction executives ask questions. When someone asks, "Why did revenue drop last week?" the estate can answer without assembling a committee. Lineage is visible and it maps to ownership and life cycle. This eliminates the most expensive activity in analytics, meetings to reconstruct causality. Sixth, cost behavior is predictable in business terms. Not CU seconds, not utilization curves, business terms: cost per decision, cost per refresh, cost per dataset, cost per domain. And those numbers drive action. Workloads that don't justify their cost get retired. Workloads that justify their cost get protected with isolation and capacity planning. The estate can scale up or down because it knows what runs, when it runs, and why it runs. In other words, scheduling works because the platform is no longer haunted by unknown background activity. Seventh, the platform team stops being the adult in every room. In a good estate, the platform team provides guardrails and automation. Domain owners run their domains, product owners own their products, finance enforces budgets with engineering, security enforces access with policy. The platform team doesn't negotiate exceptions all day because the system denies non-conforming work by default. That's what maturity looks like. Fewer heroics, more constraints. Now the executive reality check. None of this happens because you rolled out Fabric. It happens because you stopped treating Fabric like a tool and started treating it like a distributed system that needs enforced assumptions. Executives keep asking, "Are we doing well?" Here's the only honest answer. You're doing well when the estate gets smaller, clearer, and more predictable while value delivered stays flat or rises. If your artifact count is exploding, your meanings are diverging, your capacity keeps scaling, and your governance program is updating documentation, you are not improving. You are decomposing. And the fix isn't more dashboards, it's more denial. Conclusion: the only rule that works. Fabric doesn't rot because people are careless. It rots because the platform allows creation without intent, and intent never enforces itself. If you want to stop the decay, enforce one rule. If an artifact can't declare owner, purpose, and end date, it doesn't exist. If you want the next step, listen to the next episode on Fabric capacity boundaries, what to isolate first and what to block immediately.